Hello friends, I am Risham Maji and today we will discuss about properties of perfect gases. Actually, this video is only for beginners, those who just starts study of physics, only for those. Okay, now we have to know about the laws of perfect gas and Boyle's law, Charles law, etc. What is perfect gas? A perfect gas or an ideal gas may be defined as a state of substance whose evaporation from its liquid state is complete and strictly obeys all the gas laws under all conditions of temperature and pressure. In actual practice, there is no real or actual gas which strictly obey the gas law over the entire range of temperature and pressure, but the real gases which are ordinarily difficult to liquefy, such as oxygen, nitrogen, hydrogen, and air, within certain temperature and pressure limits, may be regarded as perfect gases. Okay, and now the law of perfect gas. The physical properties of a gas controlled by the following three variables: pressure exerted by the gas, volume occupied by the gas, and temperature of the gas. The behavior of a perfect gas undergoing any change in the above mentioned variables is governed by the following laws, which have been established from the experimental results. One, Boyle's law; second, Charles law; and third is Gay-Lussac law. These laws are discussed in detail in the following pages. First is Boyle's law. Uh, this law was formulated by Robert Boyle in 1662. It states that the absolute pressure of a given mass of a perfect gas varies inversely as its volume when the temperature remains constant. So according to Boyle's law, mathematically we can say P varies as 1 by V, and when the temperature is constant, and we can say that PV equals to constant. The more useful form of the above equation is P1 V1 equals to P2 V2 and equals to P3 V3 is equals to constant, where suffix 1, 2 and 3 refers to different states of conditions. Okay, and next is Charles law. This law was formulated by Frenchman A.C. Charles in about 1787. It may be stated in the following two different forms. One is volume of a given mass of a perfect gas varies directly as its absolute temperature when the absolute pressure remains constant, and mathematically we can say V varies T, or V by T equals to constant. So we can say V1 by T1 equals to V2 by T2 equals to V3 by T3 is equals to constant. And second is perfect gas change in volume by 1 by 273 of its original volume at 0 degree Celsius for every 1 degree change in temperature when the pressure remain constant. And mathematically we have to represent this formula. So we have to assume some physical characteristics like V0 is equals to volume of a given mass of gas at 0 degree Celsius, and Vt is equals to volume of the same mass at of gas at T degree Celsius. Then according to above statement we can say Vt is equals to V0 plus 1 by 273 273. V0t is equals to V0 into T by T0, or we can say Vt divided by T is equals to V0 by T0, where T is equals to absolute temperature corresponding to T degree Celsius, and T0 is equals to absolute temperature corresponding to 0 degree Celsius. Okay, and a little consideration will show that the volume of a gas goes on decreasing by 1 divided by 273 of its original volume of for every 1 degree Celsius decreases in temperature. It is thus obvious that at a temperature of minus 273 degrees Celsius, the volume of the gas would become zero. The temperature at which the volume of a gas becomes zero is called absolute zero temperature. Okay, And next is Gay-Lussac law. The absolute pressure of a given mass of a perfect gas varies directly as its absolute temperature when the volume remains constant. And mathematically we can say P versus T, or we can say P by T is equals to constant, or we can define this equation P1 by T1 equals to P2 by T2 equals to P3 by T3 is equals to constant. Okay.